So we'll come to our discussion on sampling, estimation, and hypothesis testing. So when we're dealing with sampling, basically, we're looking at a statistical technique which we use to select a subset from a larger population. So if you are a building scientist, a lab technician, we deal with samples. And this is very important for you to know because you need to be within an exact estimate for you to give a premise of an entire population. So for instance, if you are testing a component of copper's grade, you don't need to test the entire mine to ascertain how much copper is there. You can get a sample to represent the entire population. So the entire population, if we're collecting all sampling units, we call it a census. But if we're sampling, we call it a sample. So a sample by definition is simply picking a small proportion of a big population. Are we together? So under sampling, we are going to be akin to a few words like estimation. What is an estimate? What is estimation? So by definition, estimation is simply the process of using a sample data to estimate or approximate the population parameters. For instance, the mean, the standard deviation. Our goal in this whole exercise is basically to make educated guesses about the characteristics of the population. We don't want to just say this area has so much copper, but at least want to estimate to say there is a grade of so much and so much in this particular region. So we can use a single value to represent the entire population. So that's what we call an estimation. Confidence interval, on the other hand, gives us what? A range of values from which the sample data is likely to contain the true parameter of a specified level. So there are confidence levels that we're going to use. I'll teach you a song that you need to apply. So if you're dealing with confidence interval, we're dealing with a range of values that will represent population parameter. So we're going to look at formulas like sample size, which is given by z squared, s squared over error squared. Or sample size n is given by z squared pq over what? The error. Then we're also going to use confidence interval, which is a range which is given by the what? The mean plus or minus z standard deviation over square root of n. We'll also be given confidence interval of a proportion, which is given by p plus minus z pq over n. Now don't be scared with these formulas you'll be given. All right, so let's start with our song. So there are 4 common confidence levels that you need to master. We have what we call a 99% confidence level, 98% confidence level, 95% confidence level, and 90%. The difference from 100 is called the significance level. So from 99, we get a 1% to get 100. 98, we get a 2%. 95, we get a what? 5%. And 90, we get a 10%. All together. Then when you divide these by 100, we call it an alpha level. So 0.01, when you divide the 1% by 100. 0.02, when you divide the 2% by 100. 0.05, when you divide the 5% by 100. And 0.10 when you divide the 10% by 100. The Z for a two-tiered test, in this case, for this one will be 2.58 or 2.57. This one is 2.33. This one is 1.96. This one is 1.64. Now the question is, where are we getting these figures from? So you'll be given what is called a statistical table. This statistical table has figures that have what we call probabilities. So these probabilities are areas under the graph, which is normally distributed. And how do we read these statistical tables? The statistical tables look something like this. So there's a Z table that you have that you'll be given at the end of the exam that will look like this. Now you need to understand how to read this table. I'll share it with you. So this table, if for instance you're asked to find the reading for 1.96. So you go under 1.9, 0.06, where they meet. So the probability here is 0.9750. So 1.96 will be equivalent to 0.9750. Are we together, Lisa? So I want you to try. Give me the reading for the Z of 1.64. Check in the table, what is the reading for 1.64? You go under 1.6 and 0.04. Where do they meet? Where are they meeting? 0.9495. Okay. So in Cosinati, suppose we're given 1.67. Give me the reading for 1.67.
It's going to be 0.525, 0.9525.
Okay, so 1.67. So here, it is 0.9525. Okay. All right. Are we following? So the readings are very important because this is like an X-ray. So suppose you're asked to find the reading for 2.0. What is the reading for 2.0, Lisa? We go under 2.0, check under 2.0 here. Under 0.00, this is 0. What? 9772. All right. These readings from this table. Now, it is important that you understand how to read this table because it is your guide to a lot of things. It's a normal distribution table. It shows areas under the graphs. So now, the readings from the table will help us calculate the Z values that are in here. Now, if you're going to find the Z value for 95%, the reading that you need to do is firstly, understand how to read from inside the table. So we've established already 1.64 is giving us 994.95. So if I tell you to read from inside the table, this probability of 94.95, what is the Z? You add the 1.6 and the 0.04. So I'm going to get 1.64. So if I ask you for this figure here, 95.25, what is the Z for this one? It is 1.6. Then here the number is 7. So there's 1.67. Are we together? So can somebody tell me what is the Z for this one, 99.59? What is Z for 99.59? Lisa? Just add this figure and the figure on top.
2.64.
2.64, exactly. All right. So now if I ask you to find a value which is not specifically inside here, like 9907, you get the closest. So 9906 is what we have. You can get it. You can't get 9909. You get the closest. So 9907, what is the reading there? 2.3 what? 35. You can see that. Lisa, are you following?
No.
All right. So let me repeat this. It's very important. This set table is an important tool when we're dealing with questions to do with confidence interval. So the confidence interval have Z figures here. So the basic thing that I want you to first understand is understanding how to read a Z figure, for instance, a Z of 1.23. Now this is a number that is just ordinary. So for you to go into the table, you go under 1.2 and 0.03, where they will meet, okay? Are we together so far? You get the first two numbers and the last one, more. So where they're meeting here. So let's go to 1.2 and 0.03. Where are they meeting? We'll go into this table. Where's 1.2? It is here. Where's 0.03? It is here. Where are they intersecting? 0.8907. Can you see that?
Yes.
All right. 0.8907. So can you tell me now, if I gave you a Z of 1.49, so which numbers do I get this side? 1.4, right? Then on top, which number do I get? 0.0 what? 09. Now together to make 1.49. So let's check where they're meeting. 1.4 and 0.09. Let's go to our table. So check for me 1.49. Where is it? 1.49. What are we getting? We go under 1.4 and under 0.09. Where are they meeting?
0.9319.
Oh, 0.93.
0.19. Yes.
Oh, correct.
No. Yes.
All right. So we now go to our reverse reading. So now if I ask to append up 0.9319, what is the Z for this p-value? So you just go and add, that's 1.4 and 0.09. So this is 1.49. Now I want you to give me what is the Z for this p-value? 9932. What is the Z for this value? Go in reverse, add that number and the number on top. What do we get?
2.47.
2.47. Okay. Yeah. Are we together, Lisa?
Yes.
So 2.47. Now, in that case, it will now help us calculate these values here. So if we're going to go confidence level 99, so 99%, what is our significance level at 99%? the difference from 100, which is 1%, right? 1% you divide by 2, what we divide by 100, what we get? 0.01. Then this 0.01, when we divide it by 2, we get 0. What? 0.005, okay?
Sorry, you said when we divide the 0.01 what?
By 2.
Mhm.
0.01 divided by 2. What are we getting?
0.025.
Hold on. 0.01 divided by 2, what are you getting?
0.005.
Yes. Then we subtract it from 1. So 1 minus 0.005, what are we getting?
0.995.
0.995. Now let's check for this one inside the table. 0.0995 inside the table. Let's look for it. It is equivalent to what? 0.995.
0.995.
Mhm.
Mm, It's
2.5 is the closest.
2 point what?
57.
5. It's close to both of them. 5, 7, and 50 the packet up. So you can choose any of them. That's what I was saying. The most exactly is 2.575. So that's where it is coming from here. So our Z is 2.575. Let's try 98%. What's the second step? How do we get the significance level? 2%, right?
yes.
Then what do we do? To get our alpha, we divide it by
100.
so 0.02. And this answer we divide it by 2, since the 2 tailed, what do we get? 0.01. Okay. Then subtract this 1 minus this. 1 minus 0.01. Zero point what?
0.99.
0.99. Let's look for this one inside the table now. 0.9.
It's is it 2.3? 2.32? 2.33?
Yes, 2.33. Look. So 2.33. That was Sanga 0. What? 990. The closest is 2. What? 33. All right. This is where the 2.33 is coming from. So 95% when you subtract from 100 is 5%. But I start divide 5% by 100 is 0.05. Then 0.05 we divide by 2 to 0.025. When you subtract it from 1 minus that, we get 0.975. If you read it from inside the table, we're going to see it at 1.96. Same, 90%. The difference from 100 is what? 10%. Then when divided by 100, you get 1.10 there. Then divided by 2, you get 0.05. And when you divide from 1, you get 0.950. Then here, you get 1.645, 1.65. Number, at this point, you can memorize what I've just explained here as follows. Which of it you're usually given AMA confidence levels younger? Are 4. We only have 99, 98, 90 what? 95 and 90. All right. So the difference from 100 is what? The significance level. When you divide the significance level by 100, it's just alpha. But what I'm interested is the Z. Ama Z jarife younger, ali 4. So 99% is equal to 2.58. 98% is equal to what? 2.33. 95% is 1.96. And 90% is 1.645. In fact, here to be more precise, I can put 1.75. So ndifo mshite memorize haya tatu. Ali 4. 99, 2.575. 98, 2.33. 95, 1.96. And 90, 1.645. Since you're all ladies, and ladies really have a very good memory, when somebody breaks your heart, that energy now channel it to remembering this with terrible exactness. Whatever they wore, whatever they did at that particular date. Now let's now channel that energy to something useful. So 99, 2.575. 98, 2.33. 95, 1.96. And 90, 1.645. All right. So 99%, the significance level is simply 1%. The difference from 100. Upper, 2%. Upper, 5%. Upper, 10%. Then the alpha, just divide this by 100. 0.01, 0.02, 0.05, 0.10. Sharp one. This is all I need you to master for now. All together. So let's go through the song again. Makongo. Confidence levels, give me the 4 confidence levels. 99, then?
99, 98,
Mhm.
95,
Mhm.
90.
Lisa, give me the significance levels. For 99, what is the significance level? The difference from 100, 1%. 98%, what do we get?
2%.
Percent. 95,
5.
5. And 90,
10.
10. Put your first subtract 100 minus 90, 100 minus 95, 100 minus 98, 100 minus 99. That one. That's 90. The alpha for this one is what? 0 point.
0.0.
0.01.
Here.
0.02.
And final is 0
And
point.
0.10.
Okay. Now our Z. Let's memorize this together. For 99, what do we have?
2.575.
5, 7.5. About here?
2.33.
Yeah.
1.96.
1.96. Yeah.
1.645.
1.645. Correct. All right. So with these solutions that you have now, I need you to now understand that this is where awake begins. So if you're asked, find if the mean is equal to 10 and the standard deviation is equal to 12 and the sample size is equal to 36. They ask you find a what? A 95% confidence interval. So let's do a quick, can you remember? Just give me the Z for each of these ones here. 95, 5%, 0.05, 5, 98, 2%, 0.02, 90, 10, 0.10, 99, 1%, 0.01. So give me the Z for 95%. So firstly, you need to understand that the order is as follows. 99, then power 98, and 95, and 90. Then here we have 2.5 what? 575. Then here we have 2.33. Here we have what? 1.96. If you master this order, and this is 1.645, then we are good to go, because this one is the first one, the number 2, number 3, and number 4. So let's go to this here now. What is the Z for 95%?
2.575.
Come again. What's the Z for 95%?
1.96.
1.96, correct. That's somebody else. 0.02 for this one. 1.3, correct. It's the second one. About 90%. What is the Z for 90%? 1.645. This is the last one. Okay, about 98%. Cosinati. 98%.
1.6.
Huh?
98% is 2.33.
2.33.
It's 2.33.
The second one, correct. About 10%.
1.645.
It's the third one, the last one, yeah. It's the same as 90%. 1.645. Yes. All right. 5%. 1.96, correct. 9%. 2.58 or 575, yeah. The first one here. 0.05.
1.96.
1.96. About 2%. 2.33. About 1%.
2.575.
About 0.10.
1.645.
About 0.01.
2.7575.
All right. So having known these, you need to master these ones. You have no option. 5 and 9, find a 95% confidence interval. So 95%, the formula is the mean plus minus Z standard deviation over square root of n. So what is our mean? 10. What is our Z at 95%? 1.96. What is our standard deviation? 12. And what is our sample size? 36. So square root of 36 is 6. 6 into 12 is a 2. So here you're going to have 10 plus or minus 1.96 times 2. So 10 plus minus 3.92. So you subtract and you add. So you start by subtracting. So 10 minus 3.92, 6.08. 10 plus 3.96, 13.92. So whenever we are finding a confidence interval, we find the range. For instance, you have 10 minus or plus minus 2. You subtract 10 minus 2, we get 8. 10 plus 2, we get a 12. This is a confidence interval. So now help me. Suppose you have a mean of 20. You have a sample size of 49. And you have a standard deviation of 21. And you're asked to find a 98% confidence interval. What's the formula? Who wants to help? What is the 98% confidence interval? What's the formula?
It's going to be mean plus Z standard deviation divided, no, n divided by one
So
of the two.
what does that mean?
20
20, correct.
plus minus
Plus minus. What is our Z at 98%? Lisa, what's our Z at
2.33.
2.33. Do we all agree?
Yes.
Then what is our standard deviation? 21. And what is our N? 49. So what is the square root of 49? 7. 7 into 21? 3. And here we're going to have 20 plus or minus 3 times this one, we're going to get 6.99. So how do we start first? By subtracting, right? 6 minus 6.99. We get what? 20 minus 6.99, 13.01. Then we add 26.99. Right together.
Just I have a question. Like, well, on the subtracting part, I'm a bit behind. What are we subtracting from?
20 minus 6.99 and 20 plus
20 minus
20.
20. Oh, yeah.
So this would be what? 20 minus 6.99. That's the lower bound. Then the upper bound, 20 plus 6.99. Same figure. Okay. So here with 13.01, comma, 26.99. All together.
Yes.
Right. So sometimes they'll give you a question to see whether you understood your statistics. So they'll just bring a figure like this. They'll just say, find a 90% confidence interval. Find a 90% confidence interval for a normally distributed figure with the data 2, 4, 6, 8. So what's the formula for confidence interval? It is a mean plus minus what? Z standard deviation over square root of n. So we only have two things. What is our Z at 90%? What is our Z at 90%?
1.645.
Right. So are we all agreeing that the Z is 1.645? Okay, what else can we find from this data? Our N, we have 1, 2, 3, and 4 numbers. So our N is equal to 4. Okay. Then the mean we can calculate using ungrouped data. Remember how we calculate the mean? We have 2, 4, 6, and 8. So here, this is 4, 16, 36, and what? 64. So we total up here. This plus that, 10, 20. So summation of x is what? 20. And this is 120. So summation of what? X squared is 120. Who remembers how do you find the mean? For ungroup data, how do you find the mean? Mean is got what? Summation of X over what? N. So what is our N? 1, 2, 3, 4. Our N is 4. So 20 over 4, what do we get? 5. So we found something else, at least the mean is 5. What else do we need to find? The variance or standard deviation. Firstly, what is the formula for the variance? Summation of X squared, summation of X to the power 2 over N, everything over N minus 1. Remember, I taught you this. So here we're going to have 120 minus 20 squared over 5, everything divided by what? 5 minus 1. Okay, so this will be 120. What is 20 squared? Divided by 5, we're going to get 100. And here we're going to get a what? Our N is 4. Sorry. This is 4 and this is 4. So 20 squared is 400 divided by 4, it's 100. 5 minus 1 is 3. So here we're going to have 20 over 3, which is 6.67. So what's the square root of 6.67? 2.57. Is that correct? Okay. What is the square root of 6.67?
2.58.
2.58. So our standard deviation is what? 2.58. So we now have all the things that we need. All right. Our mean is 5. Our N is 4. Our standard deviation is 2.58. And our Z is what? 90. Which is what? 1.64. Now we can calculate everything we need. So some of the information may be hidden. So we now go to compute our stuff. So now we go in here now. Where there is mean, we're going to put what? 5. Where there is Z, we're going to put what? 1.645. Where there is standard deviation, we're going to put what? 2.58. Where there's N, we're going to put what? Square root of what? 4. Then you get the answer. It's interesting now, right? But it's a lot of work. Okay. Now, for you, Lisa, let me take you to exam questions so that you see now how your papers come. So let's help her in understanding where we're going to apply. Let's look at this question here. It is known that under standard conditions, the height of a certain type of plant is normally distributed with mean 23.6. So what are we given there? Our mean is what? 23.6, right? So our mean is what? 23.6. What else are we given in that question? Our variance is what? 1.38. So how do we find the standard deviation? If that is the variance,
You square root it.
we square rooted, good. So what is our standard deviation?
It's 1.17.
1.17, correct. So now we're being asked find the 95% confidence interval for the mean of 250 plants. So what is this 250 standing for? What?
N.
N, good. So N here is what? 250. Can somebody tell me what's the formula for the confidence interval? And at 95%, what is our Z at 95%?
1.96.
Good, 1.96. So confidence interval therefore would be what? The mean plus minus Z standard deviation over square root of what? N. Where there's mean, what are we going to put? 23.6, right? Where there's Z, we're going to put what? 1.96. And where we have our standard deviation, we're not going to put 1.36 since we're going to put what? 1.9. The square root of this one is 1.17. And our N, we're going to put square root of what? 250. Does that make sense now? Is it making sense now? So it's important to master the song here. If they gave us 98%, our Z would have been what? 2.33. If they gave us 99%, our Z would have been what? 2.575. All right, so you need to know that song I was teaching you. So I'm not going to get the answer. This will be your homework. The first part is on hypothesis testing, which I'll teach later on. But the second part is on confidence interval. Then the second part, look at what they've done. They've given us these figures. And they've asked us to find what? The mean of the heights. I've taught you how to do that. You need to add them up and square them individually. And divide them by n, which is 10. We have told that 10 plants. So suppose your n, as you found, is what? 10. And your mean, for instance, is what? 20. I'm just supposing. And your standard deviation maybe you found as what? 5. Then they ask you obtain a 95% confidence interval for the new condition. So what do we do? The same we've been doing there. At 95%, the mean is what? 20 plus or minus the Z using a 95%, we use 1.96. The standard deviation you needed to have calculated, that's why there are more marks here. There's 5 marks plus the 2 marks, 7 marks. So here we're going to have what? 5 over square root of our n is 10. Can you do what I taught you? The other ones are easy. Find the standard deviation, not a problem. Find the variance, these are not a problem. So it becomes an integration of many topics. So if you don't know topic 1, which is to do with descriptive statistics, you can't answer this because we may not even know how to calculate the mean for this sample. All right. Are there any questions so far? Now this is how the tough get going. So this is what we needed to know. So I'll send you homework based on what I have explained today.